Good morning, dear students. First of all, thank you for giving this opportunity to introduce myself. So, this is Dr. Vijaya Babu. So, today I would like to give some basics on current electricity. So, the current electricity is one of the basic and most important subject. So, to understand the concepts of voltages, currents, resistances, inductance, and capacitance, so how they work together to give some required nodal voltages as well as the loop currents. Okay, so to understand about this current electricity, so first of all, one of the most important thing what you need to understand is the concept of resistance. So many times you might have listened this word resistance. So resistance is nothing but the property of the material. Okay. So resistance is the property of the material means simply I can say, so I am some material, right? So even I have some resistance. So this pen is a material, it has some resistance. So this table is having some resistance. So that means it is a property of the material. The meaning is that you cannot touch it, right? So you cannot touch it. Just you can feel the resistance, but you cannot touch the resistance. Resistor is a device or an element, okay, which exhibits the property of resistance. So I'm calling one more letter, that is what you call it as the resistor. So this resistor is the element, okay, which will try to exhibit the resistance. So now, however, the symbol for this resistor, it is well known for us. So this is the symbol what we usually call, and the units of this resistance will try to give it as ohms. Okay, so before that, before going ahead, I would like to make a small definition about this resistance. The property of the material which will oppose the flow of current. So it is a property of the material which oppose the flow of current. Okay. So instead of explaining with the definition, one thing I try to do, I try to take a small electrical circuit. Okay, and I'll try to make you understand the concept of resistance. So let us consider a battery. Okay, of 8 volts, and I'll try to connect a resistor in parallel with this battery, something like this. Okay, in parallel I have connected. So let us assume the resistance value, let us assume, take it as 2 ohms. Just it is an example what I took. A small electrical circuit, a simple loop, a one loop phenomena. Right. So now I'll try to calculate the current through the resistor, how much it will be. So the current through the resistor is simply, I think from the Ohm's law, you well known that the current I is equal to V divided by voltage across the resistor divided by the resistance value. Right. So that means it is the 8 volts divided by, what is this value? This is 2 ohms. So 8 by 2. So it is 4 amperes. Now something I try to do, I try to mark the current in the loop, something like this. So quickly understand. So this current, how much I got? 4 amperes. If you ask me the current entering the 2 ohms, 4 amperes. If you ask me the current coming out of the resistance or resistor, 4 amperes. The current entering the negative terminal of the battery, 4 amperes. The current coming out of the battery, 4 amperes. So unfortunately, the definition what I told you is violated this practical example. Yes or no? I said it opposes the flow of current, but in this loop, in a simple loop, the current, the resistor is not opposing the flow of current. Okay, the same amount of current, that is 4 amperes, is running throughout the loop. Okay, so with this example, I cannot justify the definition. Okay, what I said. So I'll try to take one more example for better understanding of this definition. So the next example, what I try to consider is simply, so the same 8 volts battery, same 8 volts battery. Now I try to connect two resistors in parallel. So that means two resistors in parallel. So let us consider this is one resistor, something like 2 ohms. The resistance value of this resistor is 2 ohms. And I'll try to consider one more resistor in parallel. Okay, something like this. And the resistance value is something 4 ohms. Okay, now from this example, so I try to calculate the current flow through resistor 1, the current flow through the resistor 1, I'm calling it as I1, and the current flow through the resistor 2, I call it as I2. Now the total current coming out of the battery, I try to consider the current as how much? So I can consider it as, let us assume it is I. Now I'll try to calculate my target. So what is my target in this problem? Target is simply calculation of I1 and I2. This is my target to calculate the calculation of I1 and I2. So simply what can I do for this? Simply you try to replace the two resistances which are in parallel with a single resistor. I think you have a well-known formula, right? So it is 8 volts. So I try to replace the 2 ohms and 4 ohms parallel combination with a single resistance. I call it as R equivalent. So simple parallel combination, you know the formula, right? So that is simply 2 into 4 divided by 2 plus 4. That means 8 divided by how much? 6. Now I is the total current coming out of the battery. Then how will you calculate the total current coming out of the battery? I is simply voltage by resistance, na? Ohm's law. You apply the Ohm's law. So that means I is equal to V divided by R equivalent. That means 8 divided by 8 by 6. That means this value is equal to 6 amperes. So the total current coming out of the battery is how much? So you got this current as how much now? It is 6 amperes. Once you know the current as 6 amperes, easily you can calculate I1 and I2 using the current division method. So these are the very important methods in electrical circuits to calculate the current through the individual resistances. Okay, so individual resistors, that is I1 and I2. So how will you calculate the value of I1? So I1 you can calculate using the opposite resistance. The formula is something like this: opposite resistance by total resistance, that is 2 plus 4 into total entering current. Total current is how much? 6. So I try to simplify this. So cancel these two. I1, I'll be getting it as 4 amperes. Similarly, I try to calculate the current flowing through the 4 ohm resistor. So if I try to calculate the current through the 4 ohm resistor, then it is simply opposite resistance, that is 2 divided by, okay, so the total current, total resistance 2 plus 4 into 6. That means 2 divided by 6 into 6, that is equal to 2 amperes. Okay, so this is how I have calculated the two currents. The current I1 is equal to 4 amperes and the current I2 is equal to 2 amperes. Now, if you clearly observe the point, even this current division formula is is required for only calculation of I1. Even for the calculation of I2, current division is also not required, right? That means the current I1 is nothing but total I2 is nothing but total current I minus I1. This is called KCL. In electrical circuits, there are a lot of methods. It's up to you what is the method you can use. Okay, current division for I2 is not required. Simply by using this KCL also, you can calculate the value of I2. Okay, just I want to enlighten you with a different method for the calculation of I2. So now finally I got I1 equal to 4 amperes and I2 equal to 2 amperes. Now once you try to observe the definition of resistance. So what is the definition of resistance? Resistance is the property of the material which is opposing the flow of current. Now observe the 2 ohm resistor. What I have took here? What is the current entering through it? It is 4 amperes. Okay. Now observe the current through the 4 ohm resistor. Okay. What is the current entering through it? It is simply 2 amperes. So the low resistance 2 ohms is allowing more current and more resistance 4 ohms is allowing less current, that is 2 amperes. Once again, I would like to quote this point once again. The low resistance 2 ohms is allowing more current, 4 amperes, 4 amperes, whereas the high resistance 4 ohms is allowing less current. So more resistance, less current, less resistance, more current. So now simply I can justify that the resistance is opposing the flow of current with a small example. Okay, so there are still a lot more methods to understand the concepts of electrical circuits. So in the next lectures, once again, we'll try to go ahead with all those concepts. So thank you for giving this opportunity. So this is Dr. E. Vijaya Babu signing off. Thank you.